Questions 5 through 7 of the 1998 Grade 12 Euclid Math Contest is what I will cover in this video. Questions 5a says that a square OABC is drawn with vertices as shown. Find the equation of the circle with the largest area that can be drawn inside the square. Alright, so let's first draw a small circle inside the square. So like that. And they want you to figure out the equation of that circle. Okay? So how do we do this? Well, the first thing, of course, is you have to know what is the format of the equation of a circle. It is x minus h squared plus y minus k squared equal to r squared. Now x and y you just leave in the equation. hk is the center of the circle and r is the radius of the circle. So if we can figure out these values, we can just plug them in and there goes the equation of the circle. So the first thing I'm going to figure out is the center, because I think that's the easiest one. The center is right here, and it's obviously halfway from the origin, which is here, to B, right? And the origin is 0, 0, and B is at 0, 4. So this, obviously, the center has to be at 0, 2. So that's the easy part. So therefore, HK is 0, 2. Like that. And if we can figure out R, then we have the equation. So how do we figure out R? Well, R we can figure out from the diagram. Just drop a perpendicular from A down to the bottom there. And therefore that will become a right triangle. And the distance from here to here is 2, right? Because this is 2, 2. And the distance from here to here is also 2. So we can then figure out this distance from there to there with Pythagoras. It would be 2 squared plus 2 squared, and we'll call that distance x, is x squared. So therefore 4 plus 4 is x squared, and 8 is equal to x squared, and therefore x is equal to the square root of 8. Okay? And I believe that is all we need. The only thing is that this x is not the radius. This x that I just figured out is the diameter. So that's an important thing to remember. The root of 8 is simplified to 2 root 2. So the radius is half the diameter, so the radius would be just root 2. All right? So now we have the center, we have the radius, we can plug them into this formula. So we've got x minus h, which is 0 squared, plus y minus k, which is 2 squared, to the radius squared, root 2 all squared. And this gives you x squared plus y minus 2 squared is equal to 2. And that is the equation of the circle that they are asking about. Now we move our attention to 5b. 5b states, in the diagram, DC is a diameter of the large circle centered at A. So this is DC. And AC is the diameter of the smaller circle centered at B. Okay? If DE is tangent to the smaller circle at point F, and DC is equal to 12, determine the length of DE. All right. I think I'm going to draw this out a little bit bigger to avoid making this too messy. All right, so it is much bigger now, and I'm going to start labeling these. So this is D, and this is A, this is B, C over here. This point that's tangent is F, and this is E. I'm also going to draw the tangent line to connect to B, so right here. And if a point is tangent, then that means that when you draw lines like that, it creates a right angle, like that. All right? And similarly, this can also be written for EC. So like this. You draw a perpendicular from E to C, like that. And it's actually not a perpendicular to C, it's a perpendicular more to ED. And I'll put that in there just for the sake of completion like that. That's also a right angle. Okay? So that's how you set this up. And now we can label this different values that they've given us. BC is the radius of the small circle, so I'll call that whatever you want to call it. We can call it R, or let's call it X. AB, therefore, is also X. That's also a radius. Now, AD, if you notice, is the same as AC. The reason is A is the center. So that means that DA, or AD, is 2X, like that. And I think the only other piece of information we know is that DC is equal to 12. All right, well that's helpful, because if DC is equal to 12, then that means that 2x plus x plus x is equal to 12. Therefore 4x is equal to 12, and x is equal to 3. All right, so FB is also a radius, so that's also x. FB from this point to that point. So I think at this point we can use the Pythagorean theorem to figure out the value of df. So df squared plus x squared is equal to db squared. You mixed letters and lines, but that's okay, you understand. df squared, therefore we have x is 3, so that's 9, and then db was from here to here, which is 3x, so therefore 3x is equal to 9 squared, like that. Right. Just solve for this. df squared is equal to 81 minus 9, and df is equal to 72, df squared rather, and therefore df is equal to the root of 72. And the root of 72, can that be simplified? 36 and 2, so 6 root 2. Right. Okay, looks like we're getting somewhere here. Now, what is the question asking us? It's asking us determine the length of DE. All right. So they want us to find the length from all the way from there to there. All right. So if you look at two triangles, DFB and DEC, you'll notice that they're similar. Similar triangles. They've got two lines that are parallel, and therefore the ratio of the sides will be similar. So using similar triangles, we can calculate the value of DE. So DE over DF, so this side over this side, is going to be same as the ratio of their bases, or the other sides, whatever you want to call them. So it would be the same as DC over DB. So like this, DC over DB, like that. If you're not familiar with similar triangles, practice a few of those questions and you'll understand it. It's actually very, very helpful and relatively straightforward to understand. So now we can plug everything in. DE is what we're trying to figure out. DF is 6 root 2. We just calculated that. DC is all the way here. So DC we know is 2x plus x plus x, so that's 4x. X is equal to 3, so that means DC is 12. And DB is from here to here, which is 3x, which therefore is 9. So solve for DE, we'll get DE is equal to 12 times 6 root 2 all over 9. And that looks like 8. 12 times 6 divided by 9 times root 2. And that's it. So DE is 8 root 2. So that is what they're asking for in this question. Calculate the length of DE, which is right here. All right. Number 6. In the grid, each small equilateral triangle has a side length of 1. If the vertices of WAT are themselves vertices of small equilateral triangles, what is the area of WAT? Okay, so we definitely need to draw this a bit bigger. And on our diagram, I will actually label in red a square box that we're going to need to use. So from there to there, and then from there all the way up there, and then from there to there, and from there to there. I'm not sure if this is a square or a rectangle, but that's a box, and we're going to need to use that because that is going to help us out. And I'm going to try to replicate that here on this bigger one. Okay, to avoid making the diagram too confusing, I just drew a segment of those small equilateral triangles, but now I'm going to draw the vertices. And the vertices of the big one look like from here to there, and then from there all the way down to the bottom, like that, and finally connecting those two. So that is WAT, and we'll label it W, A, and T. And they want us to figure out the area of that. So we can start labeling these, and if we don't know, we'll figure it out later. But what we do know, well, let's label it. What we do know is that each small equilateral triangle has a side length of 1. So from here to here is 1, from here to here is 1, and from here to here is 1. All right? And since this is half of an equilateral triangle, you can see that from the diagram here, this is going to be 1/2. So far so good. We've got 1 full length. Now we want to figure out this. Well, how do we do that? Well, we can use Pythagoras. If this is a half and this is the side and length 1, we can call this x and figure it out. So we've got x squared plus a half squared is 1 squared. So therefore x squared is equal to 1 minus a half squared, which would be 3/4, and therefore x is equal to root 3 over 2. All right, so here is root 3 over 2. All right, so far so good. Now we want to look at our diagram here and see how many of these triangles are there as we're going from the bottom all the way to the top. Well, it looks like we've got 1, 2, 3, 4, right? 4 of them. And each of those have a height of root 3 over 2. So the total distance from here to here would be 4 times root 3 over 2, which is just 2 root 3. All right? And this we can label as 1, and this we can label, let's see, it would be 2.5, right? So 2.5. And finally, this one in here, this side, we can label, it would be just 3 times root 3 over 2. Because if you look at this triangle very carefully over here, you'll see that from here, A, all the way up to the top, it's 3 of those equilateral triangles. All right, so I hope you understood how I labeled this. And now to calculate WAT, we just need to calculate the full total area of this shape, which is a rectangle most likely, and then subtract these 3 triangles. So I'll call this triangle 1, I'll call this triangle 2, and I'll call this triangle in here 3. So the full shape, rectangle, minus 1, minus 2, minus 3, will give you the area of WAT. Okay, so we're going to do it. I'm not going to just leave you. So here we go. So the full area is going to be length times width. The length is 2 root 3 times the height, which is 3.5 from there to there. So we got 3.5 like that. And then subtract from it 1. So that's 1/2 base times height. The base 2.5 and the height 3 root 3 over 2. I know I'm mixing decimals with fractions, but that's okay. Triangle 2 is 1/2 base times height. Base is 1, height is the full height, which is 3. The full height is 2 root 3. And finally, one last one, 1/2 base times height for this one, number 3, is 3.5 times this little guy here, root 3 over 2. And that's it. Now, as long as you don't make any mistakes, you should get the area of WAT. So this looks like 7 root 3. This is going to be 15 over 8 root 3 minus, looks like, root 3 and minus 7 over 8 root 3. Okay, so we got a whole bunch of root 3's here, so we can just get rid of those, factor them out, and that leaves you with 7 minus 15 over 8 minus 1 minus 7 over 8. So this is going to be root 3, 6 minus 22 over 8. And this gives you root 3, 26 over 8. And that can be simplified to 13 over 4 root 3. So that is the area of WAT. Now we move to the next one. In triangle ABC, M is a point on BC such that BM is 5 and MC is 6. If AM is equal to 3 and AB is equal to 7, determine the exact value of AC. So this length right there. Okay, before I begin, I have to do a little bit of a review. Something called the law of cosines. And if you're not familiar with it, I will explain. Let's say you have a triangle, and the triangle has the following points. It's got A, B, and C, and therefore you've got sides with lengths B. This side has length A, and this side has length C. The law of cosines states that C squared, this here, is equal to A squared, this here, plus B squared, right there. And so far it looks like the Pythagorean theorem, but because this is not a right triangle, you have to subtract 2 times A times B cos of C. So this A represents this A, this B represents this B, and this cosine of C represents the angle at C. All right? So that is something that we're going to use in this question to figure out our AC up here. Okay, so first let's look at triangle BAM. And in BAM, you will notice that we are given all the sides. So that's going to help us figure out an angle. And the angle I'm going to figure out is that angle right there, angle B, using this law of cosines. So we've got 3 squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 cos B. All right? That's using the law of cosines. And therefore, we have 9 is equal to 25 plus 49 minus 70 cos B. And if you solve for this, you'll get 70 cos B is equal to 25 plus 49 minus 9. And therefore, this looks like 40 and 25, 65 over 70 is cos B. And this can be reduced to lowest terms, 13 over 14. All right? So that's the first part of the question. Next, look at triangle BAC. This one, BAC, the full triangle. And that will help us figure out AC using the law of cosines. So we've got AC squared is equal to 7 squared plus this whole side squared, which would be 11 squared, minus 2 times 7 times 11 cos B. All right, just like that. And we can solve for this. So AC squared is equal to 49 plus 121 minus 154. And cos B, we already figured out, was 13 over 4, 13 over 14. And we can then do the math here. This looks like 170 minus 143, and that's 27, and therefore AC is equal to the root of 27. So that completes number 6. Now move on to number 7. The function f at x has a period 4. The graph of one period of y equals f at x is shown in the diagram. Sketch the graph of y equals 1/2 f at x minus 1 plus f at x plus 3 for x between -2 and 2. Okay, it will be interesting. The first thing I want to do, as always, is draw this out a bit bigger, because this is kind of small here. Alright, so I've labeled this according to what they gave me. This is 0, this is -2, and this is -2, this is -4. I've drawn it a little bit more than what they've given me. Plus 2. And this is 4, this is 5, this is 3, and I think that covers it. So now what we have to do is draw this graph right here. And to draw that graph, I think the best thing to do first is, instead of immediately attacking the graph and start plotting points, let's make a table of x values and f at x values. And when you do that, I think this will be a lot clearer. So the good news is that they don't want us to do this graph too big. They only want it from x between 2 and minus 2, so that's good. So we only need to really put in about 5 points, and that should be enough. So for x equals minus 2, minus 1, 0, 1, and 2, and that should give us enough to connect the dots. So let's just figure this out. So f at x minus 1, if x is minus 2, would be f at minus 3, like that. And what is f at minus 3? Well, this is minus 3, and f at minus 3 looks like it's 2. So that's 2. F at x plus 3 is what? If x is minus 2, it's 1. So f at 1, from our diagram, here's 1, is 2. Again, it's right there. So f at 1 is 2. So therefore, if you add them and multiply them by a half, you'd get 1/2 times 2 plus 2, which is 2. So f at x is 2 in this case, our big long equation right here. And similarly, we would just keep going. And when x is minus 2, f at x was 0. But we don't really need f at x. Anyhow, let's just keep going here. When x is minus 1, we got f at minus 2. And f at minus 2 is 0. Just from the graph, it's right here. And similarly, f at x plus 3, when x is minus 1, is f at 2. And that is 0. Because f at 2 is right here. So therefore, we have 1/2, 0 plus 0, which is 0. Similarly, we've got f at, that's minus 2. F at x minus 1 for x equals 0 is f at negative 1. And f at negative 1 is right here, which is minus 2. And then for x plus 3, when x is 0, you have f at 3. And f at 3 is right here, which is negative 2. So therefore, you've got 1/2, negative 2 minus 2 is negative 2. And f at x, when x was 0, was just 0. We don't really need it, but for the sake of completion, let's just do it. X is 1, f at x is therefore 2. This becomes f at 0, and this is 0. When x is 1, this becomes f at 4. And f at 4 is here, which is 0. And therefore, this is 0 plus 0 times 1/2, which is 0. And we're almost done. X is 2. F at x is 0. This becomes f at negative 1. Or, sorry, f at positive 1. Which is right here. Positive 2. And this becomes f at 5, which is also 2. And therefore, the last point is 2 plus 2, which is 2. So now we'll graph this on the table that or the graph that we already made. So when x is minus 2, our big long equation is 2. So minus 2, 2, right there. When x is minus 1, we've got 0, so it's here. When x is 0, our big long equation is minus 2, so it's here. When x is 1, we have 0, so it's here. And finally, when x is 2, the y is 2, so we have here. And then if you connect these to make a graph, it will basically look like this. like that. And that's all they wanted. They just wanted you to figure this out between the values of -2 and 2. So this would be the graph right there. Just highlight it for you. All right? So that takes care of 7a. Now let's work with 7b. If x and y are real numbers, determine all solutions xy of the system of equations. X squared minus xy plus 8 is 0, and x squared minus x plus y is 0. Okay? So they're saying that these two equations are both equal to 0. So we can manipulate these in some way and try to figure out what x and y are solutions that we are required to find. So looking at this, we can probably get rid of the x squares by subtracting 1 from 2. And that will probably help us out. So we'll get x squared minus xy plus 8 minus x squared plus xy plus 8x, sorry, minus y is equal to 0. So the x squared is canceled, and we've got minus xy plus 8 plus 8x minus y. Now if you rearrange it like this, minus xy plus 8x plus 8 minus y, it'll allow you to factor things out. So at this point you can factor. Let's factor this one first. You got 8x plus 1. And then from the other two, we take out a y, a minus y, and that will give you 1 plus x. And that helps, right? Because now we can rearrange this as x plus 1 times 8 minus y, like that. And therefore, x is equal to -1, and y is equal to 8. Those are the solutions. Now, to find the solutions of the system, we have to plug each of these back into these formulas. So our formulas are x squared minus xy plus 8 is 0, and x squared minus 8x plus y is equal to 0. So let's first work with x equals -1. Plug that into either of these and you get -1 squared minus -1y plus 8 is equal to 0. So 1 plus y plus 8 is equal to 0, and y is therefore equal to -9. So our first solution is x, y, -1 and -9. So that's our first solution to these system of equations, which is what they've called it, system of equations. Now to get the next solution, we need to deal with y equals 8. So I can put that into either one, either this one or this one. It doesn't really matter. Let's just put it into the first equation, and that would give you x squared minus x times 8 plus 8 is 0. And this is a quadratic equation, and I don't think it factors. Yeah, I don't think it factors because 8 and 1 or 2 and 4 unfortunately don't give you good factors, so we have to use a quadratic. That's okay. So quadratic equation, if you remember, minus b plus or minus the square root of b squared minus 4ac all over 2a. So x in this case would be 8 plus or minus the square root of minus 8 squared minus 4 times 1 times 8, like that, all over 2. So this looks like 8 plus or minus 64 minus 32, all over 2. So this is 8 plus or minus root 32, and I'll write it as 16 times 2, and that will allow us to simplify this a bit. This becomes 4 root 2 over 2, and therefore this is 4 plus or minus 2 root 2. So that led to two solutions. xy, therefore, is 4 plus 2 root 2 and 8, which is the value for y. And it also gave us 4 minus 2 root 2, 8, which is the value for y. And therefore, these are our solutions to our system of equations. We have 3 solutions. And I believe that completes 7b. Yes.